Hello students, welcome to Bio-Wise with Aanchal. Today I have come with a new concept. Basically, you all have studied about this concept, but there are many confusions regarding this. And on the basis of a comment received from a student that there is a doubt in understanding what is an acid or a base or a salt and how to identify if the compound is given to you, how will you identify it as an acid, base or salt, right? So you all actually find it very confusing to identify the compounds as acid, base, and salt. Right. There are many students who find it still challenging to identify these compounds or even test for these compounds. Okay. So, what is an acid first? So, acids are basically the compounds where the cation, that is a positively charged ion, is always hydrogen. Okay, you always remember hydrogen ions. Yes, I forgot to say, subscribe the channel if you have not subscribed, like and share to all those who need it, and then proceed with the understanding and learning. Okay, so hydrogen ions are the cations present in acid. You see any acid, whether you see anions, there are a variety of anions present, but when you see the acid, hydrochloric acid, sulfurous acid, sulfuric acid, nitric acid, nitrous acid, phosphoric acid, in all the acids, we'll find that the hydrogen ion is a common thing, right? So H plus ions are the cations present in the acids. Okay. Then you have bases. What are bases? Bases have list of cations. That is, positively charged ions will be different. But anions, when you consider, it is always OH minus ions. So anions here is OH negative. Okay. So all the bases, if you see, NaOH, LiOH, KOH, MgOH whole twice, calcium hydroxide, zinc hydroxide, copper 2 hydroxide, barium hydroxide, ammonium hydroxide or aluminum hydroxide, in all the cases hydroxide ion is common. So if you find any compound with a hydroxide ion, it is considered to be a base. Okay. But and if these cations and anions, other than hydrogen ion, if there are list of cations, and other than hydroxide ions, there are list of anions. When they form compound, they form salts like sodium chloride, lithium chloride, potassium sulfide, calcium sulfate, zinc nitrate, copper nitride, barium phosphide, ammonium chloride, aluminium phosphate, all these are salts. You can see in all these cases, none of them have cations as hydrogen ions, and none of these have anions as hydroxide ions. And when you get cation as hydrogen ion and anion as hydroxide ion, then there is a formation of water, a neutral compound. Understood? So, this is all about acid, base, and salt on the basis of cations and anions present in it. Okay, so all acids have fixed cation, that is hydrogen ion, and all bases have fixed anion as hydroxide ions. Bases will not have H plus as cations, and acids will never have OH as anions. Understood? Hydrogen ions and OH minus ions form water, that is what H2O. Now, when you talk about acid, base, and salt, there is something called pH scale, which starts from 0 to 14. I'll give you a very basic idea. This scale, on the basis of different colors, tells you what is the pH of the solution. These are certain common things present in our kitchen, home, in our body that has different pH, right? Like, for example, if you talk about acids, lemon, tomato, they are acidic. Stomach acid, your HCl in the stomach, pH is 1 to 2. Vinegar, coffee is slightly acidic, milk is slightly acidic, water is neutral, that is 7 pH. And these pH, when you study in your higher classes, you'll understand these are on the basis of hydrogen ion concentration present in the solution. Understood? So this is, then you have blood, 7.4 pH. So the tablets that you, antacids that you take, ENO or magnesium hydroxide, milk of magnesia, that is magnesium hydroxide, it neutralizes the acid present in your stomach. Drain cleaner, soap, they're all basic in nature. Okay. There is a test called litmus test for acids. Litmus paper is basically a purple color paper, which is used to test whether the given solution is acid or a base. Acid, if you put the litmus paper in acid, the litmus paper turns red. If it is already red, it will remain red. Understood? But if you put it in a base, it turns blue. B for blue, B for base. Understood. For neutral solutions, there is no change in color. If you take a blue litmus paper, put it in a neutral solution, no change. If you take a red litmus paper, put it in a neutral solution, there is no change. Okay, there is no change in the color of the litmus paper if you put it in a neutral solution. But the color is to red if it is put in acid, and the change of color is to blue if it is put in base. Understood? If you take same color, then obviously you'll write that no change is observed. Like for example, if I tell you that what will be the observation when a red litmus paper is put in an acidic solution. Now acidic solution mein litmus remains red. So red litmus paper will remain red in the acidic solution, but the blue litmus paper will turn red. Understood? So writing has to be when you understand the question well. Then methyl orange indicator. Methyl orange is again red. Red is for danger and acid. It is red in acid and it turns to yellow in basic solutions. Phenolphthalein indicator. Now phenolphthalein is basically phenolphthalein is in pink color is in the base. Now you tell me A or B, which one is basic? Write the answer in the comment section. Which solution is basic? A or B? Write the answer in the comment section. Okay. So strongly basic may you'll have dark pink color. Weakly basic may you have pink coloration. And acidic may you have basically colorless solution. So which one is more basic, A or B? Write it in the comment section. Then formation of acids. Generally, when non-metallic oxides react with water, they form acid. That is why they are called acidic oxides. Okay, so any non-metallic oxide, if you take like SO2s, that is sulfur dioxide, carbon dioxide, sulfur trioxide, phosphorus pentaoxide, nitrogen dioxide, these are all acidic oxides. Now, there are certain oxides which are neutral, like H2O. H2O is also an oxide of hydrogen, which is neutral. Carbon monoxide is neutral. Right. So when these non-metallic oxides react with water, they form acids. Fine. Like here, this is also for acid rain, the first reaction, and even the last reaction is for acid rain. So SO2 plus water will give you sulfurous acid. Carbon dioxide plus water will give you carbonic acid. Sulfur trioxide with water will give you sulfuric acid. Phosphorus pentaoxide with water will give you phosphoric acid. Nitrogen dioxide will give you a dual acid, that is nitrous as well as nitric acid in the product side. Understood? This is how the acids are formed from the acidic oxides. And what are acidic oxides? The non-metallic oxides are the acidic oxides. Exceptions are there like carbon monoxide, H2O, these are NO, these are all neutral oxides. Then what are bases? Bases are formed when metallic oxides react with water. What are the metallic oxides like sodium oxide, potassium oxide, magnesium oxide, calcium oxide? When they are dissolved in water, they lead to the formation of bases, right? Like NaOH, that is sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide. And these are called basic oxides because they lead to the formation of bases. Understood? There is one more group of metals which form amphoteric oxides. Now, amphoteric oxides, they do not dissolve in water. So they neither form acids nor bases. But there are only three metals which gives amphoteric oxides. Remember ZAP. ZAP is what? Zinc oxide, aluminum oxide, and lead oxide. The amphoteric oxides generally do not react with water. They are insoluble in water and they do not form acids and bases when mixed with water. They are amphoteric because they behave as acids as well as bases. Like in bio, we have no amphibians which can live on land and water. Similarly, these oxides can react with acids to give salt and water. They can also react with bases to form salts. Understood? So that is why they are amphoteric oxides. Then the reaction between an acid and base to form salt and water is called a neutralization reaction. I have marked the acids with red and bases with blue so that you can understand the cation anion movement. Now acid ka anion and base ka cation will form salt. And whatever is left, H and OH is left, which will form water. So H2SO4 when reacts with sodium hydroxide, you have sodium sulfate and water. So hydrogen chloride, that is hydrochloric acid, and NaOH, that is sodium hydroxides, form sodium chloride, common salt, and water. The H2SO4 and potassium hydroxide, potassium sulfate, and water. Hydrochloric acid and potassium hydroxide, potassium chloride, and water. In all the cases, you'll find water is common, and salt is common, right? So whenever an acid and base reacts, they form salt and water. Then there are certain other reactions like acids and bases you can go through. You can pause the video here, take the screenshot, write the reactions, check whether they are balanced or not. Am I correct? Write in the comment section that all the balancings are done correctly, or is there any mistake in the slide? Find out. Okay. So these are all kind of neutralization reaction. Always remember, neutralization reaction is a kind of double displacement reaction. Precipitation reaction is also a double displacement reaction. Neutralization reaction is also a double displacement reaction, that is cations and anions are exchanged. So acid and base reacts to form salt and water. Then what are bases and what are alkali? You remember the group 1 elements? We call it alkali metals, right? Group 2 alkaline earth metals. Now, whenever these metals form their bases, they are dissolved in water. So they are called alkali. So when you have to define a base is a substance that neutralizes an acid to form salt and water. Alkali is a base which is soluble in water. All bases are not soluble in water. Only the bases which are soluble in water is called an alkali. Right. So solubility is also different for bases and alkali. Hydroxide ions is produced by the bases only when they are soluble. If they are not soluble, they do not form bases. In precipitation reaction, we have seen that copper hydroxide precipitates down and gives a pale blue precipitate, right? And even ferrous hydroxide, ferric hydroxide, they all form precipitates. That means they are not soluble, insoluble ones, right? So nature, they can be solid, insoluble substances, and alkali is always in water soluble base, always aqueous solution. Copper oxide, zinc oxide, magnesium hydroxide, they are all kind of bases. Okay, all bases. Soluble, insoluble is not there. All base. Alkali, water soluble. Remember the group 1 elements and group 2 elements, right? Then all bases are not alkali, but all alkalis are bases. The statement is very important to understand. What are the basic uses of acids? Hydrochloric acid helps in digestion in the stomach. Acetic acid is present in vinegar, used in cooking. Your Chinese stuff and all is prepared from the acetic acid. Citric acid found in lemon, orange, used in soft drinks and food. Sulfuric acid is used in car batteries. Carbonic acid is used in aerated drinks. Then bases, making soaps and detergents, sodium hydroxide is used. Calcium hydroxide, also called slaked lime, is used in whitewashing walls. Then magnesium hydroxide is used as an antacid, milk of magnesia. Ammonium hydroxide is used in cleaning cars and floors. Toothpaste neutralizes acids in the mouth. The toothpaste are also slightly basic, okay? So all the acid content of your mouth is neutralized. So the enamel does not go bad, right? Then certain salts like common salt for cooking, sodium bicarbonate for baking cakes and antacids, sodium carbonate for washing clothes and softening hard water, calcium sulfate, that is plaster of Paris. Write down the formula of plaster of Paris in the comment section. Making casts and statues. Then ammonium chloride, electrolyte in rice. You can also write the ammonium chloride ka formula in the comment section. Okay, I hope I have made the concept of acid and base very clear in your mind. If you agree, give a like, share, and subscribe before leaving. Thank you, children. Happy learning. Because now I think chemistry is making sense, okay? So, do well. All the best for your exams.